Welcome to another physics class. During our last lesson, our discussion is on impulse and momentum. And when we concluded on that day, I promised that in our next video, we are going to look at work example on linear momentum, Newton's second law of motion, and impulse. So before we continue, recall one, that momentum P is equal to mass times velocity of an object. At the same time, number two, we talk about change in momentum. Change in momentum, that is delta P is equal to final momentum minus initial momentum, mv minus mu. So from there we are going to have, since m is constant, m into bracket v minus u. That is change in momentum. Then from there, we now move to Newton's second law of motion. That is number 3 from Newton's second law of motion. We said F is equal to change in momentum over time. That is, the rate of change of momentum is directly proportional to the force applied. Then, after that one, we now say that from this Newton law of motion, that is number 4, we can say that F is equal to ma, that is mass times acceleration. And finally, when we concluded, that is will be number 5, we say impulse will be equal to, that is I, will be equal to Ft, which is equal to delta P, that is change in momentum. So today, our calculation will be based on the formula on the board. Now, let's take this one as example 1. A body of mass 3.0 kg moves with a velocity of 10 meters per second. Calculate the momentum of the body. Now, let's write out the parameter within the question. Mass is given, that is 3 kg. 2. Velocity is given, that's 10 meters per second. Then, what else is given? We have to calculate momentum, that is P. So we can now say that from the formula on the board, our momentum, P, will be equal to mv, that is mass times velocity. So from there, we can now say that that's 3 multiplied by 10. So without wasting time, the momentum of this body will be equal to 30 kilogram meter per second. Kilogram meter per second. That is example 1. Take this one as example 2. A stationary ball is hit by an average force of 50 Newton for a 0.03 second. Then what is the impulse experienced by the ball? Now, from this question number 2 also, let's write out the parameter given in the question. 1. Force is given, 50 Newton. At the same time to exert the force is 0.03 seconds. Then we now have to calculate impulse. Now, according to the formula, impulse I will be equal to Ft, that is force multiplied by time taken. And F is given as 50, that's 50 multiplied by 0.03 seconds. And the answer will give us 1.5. Then from there now, this is Newton, this is second. 1.5 Newton second are the unit of impulse. Take this one as example 3. A body of mass 2.5 kg initially at rest, is acted upon by a resultant force of 10 Newton. Calculate the acceleration of the body. Now, as usual, let's first write out the parameter. In this question, mass is given 2.5 kg. Then force is given F 10 Newton. Then we now have to calculate acceleration. A is not given. Now, if you look at our formula on the board, already we've known that F is equal to ma, but we need A. Then A now is equal to F over F over M. And what is our F? That is 10. M is 2.5. So the answer will be 4 meter per second square. Let's take this one as example 4. A ball at rest is killed by a footballer with force of 30 Newton for a 0.05 second. The mass of the ball is 0.075 kilogram. Calculate the speed with which the ball moves off. Now, let's write the parameter given in this question. The first thing, force is given. F is given as 30 Newton. Again, time to experience the force by the ball. T is 0.05 seconds. 0.05 seconds. Mass of the ball is given. M is given as 0.075 kg. Then we have to calculate the speed. Speed, V, we have to calculate the speed. Now, from this question now, the question says the ball is at rest. It means the initial speed, that is U will be equal to 0 since the ball is at rest. So if that is the case now, to write one of the formula on the board, we can now say that F is equal to delta P over T. And from there, to express further, we can now say F is equal to mv minus mu over T. To express this one further, because mass is the same, we can now say F is equal to m into v minus u over T. So from there now, all the parameters on the board present in the formula will be written last. So we can now say that F is given. We need V. So from there now you can now say Ft will be equal to, since U is equal to 0, so we are now left with mv because we need V. So we can now say that V now is equal to Ft over m. Ft over m. So to write out all, to substitute the value for the variable we have. So V now will now be equal to, our F is given as 30, T is given as 0.05 seconds. Then M is given as 0.075. So V now will be 1.5 divided by 0.075. And finally, V will be equal to 20 meter per second. Let's take this one as example 5. When a force is impressed on a mass of 25 kg for 5 seconds, the velocity changes from 12 meter per second to 15 meter per second. Calculate the A, initial momentum, B, final momentum, C, magnitude of the force impressed on the body. Now, solution. From the question on the board, mass is given, M. as 25 kg. Then for 5 seconds, time is given 5 seconds. At the same time, change from 12 meters per second to 15. The initial velocity u is given, that is 12 meters per second, and the final velocity v is given as 15 meters per second. Now the first question says we should calculate the initial momentum. So initial momentum, that is mu. That will be initial momentum. So that is P will be equal to mu, and our m is 25. That's 25 multiplied by 12. So the answer will be, as I said, 300 kilogram meter per second. That is the initial momentum. B, to calculate the final momentum, P final, P initial, P final, that one will now give us mv. So m is the same, that is 25 multiplied by 15. So this one will now give us 375 kilogram meter per second. The next question says we should calculate the force impressed on the body. That is question C. To calculate the force impressed on the body, go back to Newton's second law of motion. So we can now say F will be equal to delta P over T. And luckily on the board, we've known that our MV is known, then our mu also is known, then over T. So this one will now give us our mv is 375. That is minus 300. Then the time taken, according to the question, is 5. So the force impressed on the body will now be equal to 375 minus 300. That is 75 over 5. So the final answer, which is the force, will be equal to 15 Newton. Let's take this one as example 6. A tennis player hit a tennis ball of mass 0.25 kg with an impact force lasting for 0.01 seconds. The ball leaves the racket with a velocity of 25 meters per second. Calculate the A, momentum gain of the ball, B, impulse of the force, C, impact force on the ball. Now, solution to this one now. Let's write out the parameter on the ball. A tennis player hit a tennis ball. Mass is given 0.25 kg. The impact lasts for time is given. T is 0.01 seconds. Then the ball leaves the racket with velocity of, that is final velocity. It means this tennis ball is initially at rest. If it is initially at rest, then the initial velocity u will be equal to 0 meter per second. Then the final velocity is given. V is 25 meter per second. Now the first question says to calculate the momentum gain. Or in another way, they can say change in momentum. It's still the same thing. So from the parameter on the ball, to calculate the momentum gain, that is question A, which I said is the same thing as change in momentum. That will equal to final momentum, mv, then minus mu, initial momentum. But according to the question now, since u is equal to 0, so this one will be equal to 0. Then we are now left with the momentum gain will now equal to mv, then which is equal to 0.25 multiplied by the velocity on the board is 25. So the answer to this one will give us 6.25 kilogram meter per second. That is the momentum gain. Then the next question says we should calculate the impulse of the force. So B now, that is I, and don't forget from here we say impulse is equal to ft, which is equal to change in momentum. It means this one will now also be equal to delta P, as we have calculated on the board. It will be equal to 6.25 kilogram meter per second without wasting time. His impact from this is question C. So that will be the impact force. According to this formula, that will be delta P over T. So that will be delta P, which is change in momentum, gain in momentum over time taken. And from here we are gain in momentum at 6.25. So it will be 6.25 then over 0.01 second. So the final answer will be 625. This is force Newton. That's the final answer. Let's take this one as question 7. A ball of mass is 0.1 kg drop from a height of 8 meters to a hard floor, bounce back by a height of 2 meters. The ball is in contact with the floor for 0.1 second. Calculate the 1. Impulse on the ball. 2. Force experienced by the ball. Now, let's solve this question now. Now, from this question, mass of the ball is given. M is given as 0.1 kg. The height from which is being dropped, H, is given 8 meters. On hitting the hard floor, the ball bounced by another height. Call this one H1, H2, 2 meters. Then in contact with the floor for T is equal to, that is time is equal to 0.1 second. Now we are now have to calculate the impulse. Now impulse, I, according to the formula, we have I is equal to Ft. Now, if you decide to say I is equal to Ft here, first, we don't know. We have to calculate the force in the second question. Though we need, the time is given. So because we don't know force now, that is impossible now to use I is equal to Ft. So we can now say I is equal to delta P. And don't forget our delta P is mv minus mu. That is the final momentum minus initial momentum. How are we going to go about this one? Find, since m is known, but v and u is not known. Don't forget, under this platform, we done the topic motion under gravity. So we now fly back to what we have done under motion under gravity to solve this problem. When the ball is moving from that height to the ground, we said the correct formula to calculate the V there will be equal to V is equal to V square, U square is moving down plus 2G8 because G is given in the question. And this our H will be H1, the height that we call H1. Now, when it is moving down from certain height, and this is another opportunity, if you are just joining up on this platform, please, to understand this question better now, you can click and open to that our topic, motion under gravity. So by the time you watch that topic, you'll be able to grab what we are doing under this one now, because we are just applying the formula here with prove all the formula under motion under gravity. So let's continue. Now, when it is dropped from this height, u at that particular point is equal to 0. And if u is equal to 0 at that particular point, we are now left with v squared is equal to 2gh. H is already given, g is already, so we can now say v now is equal to square root of 2 multiplied by 10 multiplied by 8. So multiply everything together. To multiply, this one will be 80. That is the square root of 160. And the square root of 160 will give us 12.649. Then if we approximate, our v now will equal to 12.65 meter per second. That is for final velocity. Now, to find our initial velocity, because there must be change in momentum when the ball hits the floor and bounce back. Now, don't forget our explanation again. When it's bounced back and raised to height of 2 meters, we are going to apply the first formula. V squared is equal to u squared, then is bound back minus 2gh. Why is it minus? Because it's gain against gravity, moving against gravity. So that is why it is minus. As I said earlier, for you to understand this question better, please try as much as possible to watch our video on motion under gravity. We explain it on detail under that topic. So from there now, we can now say that when it moves up, the final velocity at that particular height, which is 2 meters, v will be equal to 0. That is when it moves up to a certain height, final velocity at that particular point will be equal to 0. So, but the initial velocity now that we need, that is mu that we need, will now come up. So we are now going to say, from there now we are going to have, see this one is 0, so we have u squared is equal to 2gh. And this, our h now will be equal to h2 that we may mention, which is 2 meters. So we are going to have u now equal to square root of 2 multiplied by 10 multiplied by 2. So without wasting time, our u now equal to 40. That's square root of 40. And square root of 40 will be equal to 6.325. And approximately u will be equal to 6.33 meter per second. So now it is now possible for us now to calculate change in momentum. Since we know our v, which is final velocity, and our u is already known, we can now say that the impulse now, that one will equal to mv minus, mind you now, for momentum to change under this one, the motion, the object, the ball is moving downward at the height of 8 meters. When it bounced back, it moved up to the height of 2 meters. If you look at this motion now, when it bounced back, the motion is opposite to this one. And when it is opposite, so it will be minus mu. That is, according to what we have written here, this is the real formula. But what will determine our calculation now is the direction of the motion of that ball. It falls from certain height, hit hard floor, and bounce back. So the motion is like this. This one is coming like this, and this one is going. The motion is opposite to each other. That is why the minus, according to the law of vector, the direction will affect this one. That is why it's changed to minus. So you can now say that mv minus times minus will give us plus. That's plus mu. So from there now we can now say that m is the same. That is v plus u. So here now the change in momentum or impulse will now be equal to, since P is known as 12.65 plus the U we calculated 6.33. Then M is already given on the board. So we can now say 0.01 kg into bracket 12.65 plus 6.33. That will be 0.1 into 18.98. Then multiply this one by 0.1. And the change in momentum impulse equal to 1.898. According to the formula we use now, the unit cannot be Newton meter. It will be kilogram meter per second. Kilogram meter per second due to the formula that we apply. That will be change in momentum or impulse on the ball. The part B of the question, that is B, the force now. Already we've known that force is delta P over T. And we calculated our delta P, which is the same thing as simple. That will be I over T, which is equal to 1.898. And the time taken for that ball to impact on the ground is 0.1. So 0.1 with this one will give us 18.98 Newton. That's the answer to B part. Now, to this end, we are going to stop for today. But if you still have any question, as I always say, you can ask your question from the link of the WhatsApp under the platform. If you are just joining us, please try to like, share, and subscribe. So when I upload a new video like this, you will be able to see the notification. Thank you.